I'm Lee, and this is NASA Now. At any given time, there are about 3,000 aircraft flying over the United States. We'll tell you what NASA engineers are doing to make our airspace safer and more efficient. That's ahead, but first let's find out what's happening at NASA now. An estimated 1 billion passengers will travel by air in the year 2012. NASA is currently researching the next generation of aviation concepts. One of them is called the EDA, Efficient Descent Advisor. This is a tool for air traffic controllers that synchronizes the descent of arriving planes. Engineers say EDA would be more fuel efficient, would minimize noise and emissions while avoiding other traffic. And Juno is on track to launch this summer. Hey, Juno looks like an armored tank and is heading to Jupiter, which has more radiation than any other place NASA has ever sent a spacecraft, except for the sun. Juno will have to withstand the equivalent of more than 100 million dental X-rays. The mission hopes to shed light on how planet formation unfolds in other solar systems. Now let's take a look at the past.
The year was 1925. That's when the first control tower for an airport was made. The tower was located in Northeast Ohio at the Cleveland Hopkins International Airport.
NASA aerospace engineers are working on the next generation of aviation concepts for keeping our airspace safe and efficient. Here to fill us in on some tools they're developing is Aerospace Engineer Aisha Bowe from NASA Ames Research Center in Northern California.
My name is Aisha Bowe, and I am an aerospace engineer in the Aviation Systems Division at NASA Ames Research Center in Northern California. In the upcoming years, it's anticipated that the level of air traffic demand will increase significantly. In order to accommodate this, NASA is investigating and developing technologies or tools that are concerned with increasing capacity, efficiency, and safety of the national air transportation system. At present, air traffic controllers direct air traffic on the ground and in the air. This is primarily done to avoid collisions, but also provides a really effective way to organize the flow of traffic, expedite it if necessary, and also prevent collisions between aircraft. The act of preventing these collisions is called maintaining separation. Separation, you can think about as an aircraft being in the center of a hockey puck, right? And the hockey puck is 5 nautical miles across and 1,000 feet high. When the aircraft are flying through the sky, they both form hockey pucks, and we don't want these hockey pucks to touch. With the increase of traffic that we're seeing, or that we anticipate, we're concerned that there are going to be possible losses of separation, which is what we call when the borders of these hockey pucks touch. And we want to prevent this. In order to do so, we're investigating ways in which we can automate portions of the air traffic system through the development of technology. No matter what decisions are made, safety is always the #1 concern, and there's always redundancy in the system. Redundancy is when you have multiple layers of safety. It's sort of like when you go outside and say you want to go roller skating, right? You might put on your knee protectors, your elbow protectors, and wear your helmet. That, in some sense, is somewhat like redundancy. You have multiple ways in which you are making yourself safe from becoming hurt. Right now, I'm focusing on evaluating the way aircraft avoid each other while en route. Typically, aircraft have been rerouted based off of minimum delay, but as environmental concerns are becoming more pressing, there's been some interest in seeing if we can reroute aircraft who are predicted to lose separation, remember the hockey puck, and see if we can do maneuvers that are fuel efficient and compare them to ones that are time efficient. In doing so, I have to make the trade-off in that I need to look at the fuel efficiency, the total fuel efficiency of the flight over the entire journey, as well as the amount of delay that's created by increasing the fuel efficiency, and see if this is acceptable. What I found through the use of simulation is that by using fuel-efficient routes, the delay of the aircraft increased significantly. This wasn't deemed appropriate because it caused the system to be extremely out of balance. Even though we saved a lot of fuel, we increased the delay significantly. Flights were hours, half an hour late, and this is unacceptable. In order to deal with this, the next step will be looking to strike more of a balance by seeing if we can get the same increase in fuel efficiency, but for lower delay amounts. This would be more acceptable. Here at NASA, I get the opportunity to not only see planes on a daily basis, I get to run simulations that are nearly exact copies of how these things behave. And that's amazing.
Did you know that the windows in an airport control tower must be tilted out at exactly 15 degrees to minimize reflections? If not, the controllers would see the reflection of their own equipment. Now you know.
Hey, now it's time to check out What's Up?
Go to the NASA Explorer School's virtual campus and look for this link. Click on it so you can see the number of planes traveling across America during a 24-hour time period. You'll be amazed at just how crowded our skies are.
Here's some cool activities for you and your classmates to work on.
First, you can construct your own dodecahedron. A dodecahedron is a 12-sided object. Each face is shaped like a regular pentagon and features a different NASA aircraft. After you've finished creating your dodecahedron, then hang it from your ceiling or place it on a shelf in your classroom. Plus, there's a cool interactive game that tests your skills at lining up planes on a virtual runway. For more information on these and other cool activities, go to NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Be sure to tune in next week when you will learn what extremophiles are all about. We'll see you then on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.